All right, ladies and gentlemen, we've made it to the final standard if you're watching this in chronological order, 7.SP.8. Ignore this, I had to restart the recording, so ignore that. Let's get right into it. A fair coin is flipped 3 times. What is the probability that the coin lands heads up once and lands tails up twice if the order does not matter? So, here's our possibilities. You have heads, 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 tails, heads, tails, heads, heads, tails, tails. Okay? So you have all 3 lands heads, the first 2 lands heads, the third lands tails, heads, tails, heads, heads, tails, tails. You're trying to cover all the options. Now, if your first throw lands tails, your second one can land heads, and then heads. Your second one can land heads, and then your third lands tails. Or your second one can land tails with your third landing heads, or your second one can land tails with your third landing tails. You can get all tails. So the question says, what is the probability that the coin lands heads up once and lands tails up twice? So we need to look for how many options. There's 8 total options. How many options does that happen? So look for, here's heads, tails, tails. That's 1 heads and 2 tails. Here's tail, heads, tails. That's 1 head and 2 tails. And here's tail, tails, heads, which is 1 head and 2 tails. 3 possible options out of 8 makes 3 out of 8. Question 2. No calculator allowed. Ariane drives by a stoplight near her home every morning. The stop has red, yellow, and green lights. She wants to know the probability of the light being red on 2 mornings. What list represents the sample space for 2 mornings at the stoplight? Okay. She drives past the stoplight near her home once every morning. It has red, yellow, and green. She wants to know the probability of that light being red on 2 mornings. So we have the option of red, 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 yellow, red, green, yellow, red, yellow, 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 green, or green, red, green, yellow, green, green. Which list represents the sample space for 2 mornings at the stoplight? So we could either have red, 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 yellow, red, green, yellow, red, yellow, 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 green, green, red, green, yellow, green, green. D. That's all the possible options you can have. Either you hit the light red on the first time, and then there's the 3 options of red, yellow, green the second time. You hit the light yellow the first time, and there's the options of red, yellow, green the second time. Or you hit the light green the first time, and there's the options of red, yellow, green on the second time. Question 3. Kayla rolls 2 fair number cubes, each numbered 1 through 6. She needs to roll a sum of 9 or more to win the game. She rolls the number cubes 1 at a time. She rolls a 5 with her first number cube. What is the probability she wins the game? She needs to roll a 9 or more. She already has a 5. So that means she needs a 4 or higher. You can get a 4 or higher on a standard number cube of the 6 possible options on 4, 5, or 6, which means you have a 3 in 6 chance of getting it right, or a 1 in 2. All right. Question 4. 2 students are randomly selected from a group of 3 students, Kim, Pat, and Sue. Which set represents the sample space for selecting these 2 students? So you can either have Kim and Pat, Kim and Sue, or Pat and Sue. It doesn't matter what order they're chosen in, because if you have Pat and Kim, that's already covered by this option. If you have Sue and then Kim, that's covered by this option. And if you have Sue and then Pat, that's covered by this option. realistically, there's only 3 possible options. So it is C. Evelyn, Brooke, and Peyton are sitting in a row. How many different seating arrangements can there be? I want to double check that I'm remembering this correctly, so please hold on 1 second. I have confirmed that I was going to do this correctly. So, when you have 3 possible options, or when you have a number of possible options, you're trying to figure out how many different arrangements you can do. You use what's called the factorial, which is just an exclamation point. Okay. In this case, this would be 3 factorial, or as I like to call it, a very excited 3. What 3 factorial represents is 3 times 2 times 1. Because there are 3 options for who's sitting in the first seat. Once you've settled that, you have 2 options for who's sitting in the second seat. And once you've settled that, you have 1 option for who's sitting in the third seat. Okay? So, if that's the case, that means that you have 3 times 2, which is 6. 6 times 1 is 6 different seating arrangements. If they gave you more, if they gave you 5 names, a very excited 5 would have 5 times 4 times 3 times 2 times 1. You just start at whatever number is in front of the factorial and multiply all the way down to 1. But in this case, it is 6. Question 6, the final question. According to a national study, approximately 1/4 of the households in the United States own a cat. Which simulation could model the probability that a family in the United States, chosen at random, owns a cat? Flipping a coin, where heads represents a household that owns a cat. Rolling a 6-sided die, labeled 1 through 6, where numbers 1 and 2 represent households that own the cat. Spinning an arrow on a spinner with 8 equal sections, where 6 sections represent households that own a cat. Or drawing a marble with 1 red marble and 3 green marbles, where the red marble represents who owns a cat. So, 1/4. Okay? We're looking for the probability that matches 1/4. Flipping a coin, where heads represents a household. Well, we know flipping a coin is a 50-50 shot. It's 1 out of 2. That's why people use it to make decisions. Rolling a 6-sided number cube labeled 1 through 6, so there's 6 possible options, where numbers 1 and 2 represent people that own a cat. That's 2 out of 6. 2 out of 6, notably not 1 out of 4. That's 1 out of 3. Spinning the arrow on a spinner with 8 equal sections, where 6 represent the households that own a cat. This is the answer that's meant to trick you. Because if this said the 6 represents households that don't own a cat, this would be the correct answer. However, these 6 represent the people who do own a cat, so the 3/4 doesn't work. Drawing a marble with 1 red marble and 3 green marbles, making 4 marbles, where the red marble represents who owns a cat. That's 1/4. That's it. That's your answer. You're done. Whew. So, if you've been watching these in order, that is the state test review. And this has been a heck of a marathon, getting all these recorded. But man, I sincerely hope that it has helped you. And as I've said at the end of every video, if you have any questions, please let me know. I'm here to help you. I realize that a lot of errors and stuff were made, especially in the videos that were posted on today, April 1st. And that's because I've been, I taught this morning and I've been recording since about 4 o'clock. So for about 5 hours after about 8 hours of teaching. So mistakes will happen. Okay? But again, I sincerely hope this helps you. If you have any questions, please let me know. And good luck on the test.